Hi, my name is Moab, and today I'm going to present my work, which is a collaboration with Ariel Shamir and Amit Bermano from Tel Aviv and Reichman universities. In our work, we present a new attention layer for neural networks that is shift invariant, efficient, and expressive. Vision transformers are among the most promising vision models today. They use self-attention on image patches, where every patch can attend every other patch in the image. Although VITs are promising, they hold several limitations. First, they shine mostly with a lot of data, or with heavy augmentations and regularization. Second, they have quadratic complexity, both in terms of computation and memory. And finally, while locality is well established prior for image-related tasks, the average receptive field of VITs is typically large. Therefore, the network can miss local features, hurting the model's performance on small-scale objects. These limitations are mitigated using local self-attention, where self-attention is applied separately on small image windows. However, this limits the interaction across windows, which hurts the model accuracy. To alleviate these shortcomings, we introduce Q&A, which is short for query and attend. Our solution is inspired by both self-attention and convolution approaches. Similar to convolutions, our layer is naturally local, but it's still attention-based, allowing more expressive nonlinear combinations. Our layer is shift invariant, like convolutions, and most importantly, it is also quite efficient. In our method, small patches are projected to form the input tokens. But instead of the usual self-attention module, where queries are extracted from the input, we use learned queries. These queries are shared across image windows, allowing efficient implementation of an attention mechanism. More specifically, the query key.product is calculated once for the whole input instead of each window independently. During training, the network optimizes the queries in order to capture features in high-dimensional subspaces, and the queries are updated via backpropagation in each training step. Here, you can see a comparison between various methods of single-layer latency and memory usage during forward pass for different kernel sizes. Q&A has low latency, even for large kernels. It also uses much less memory, and most importantly, it is independent of the kernel size. When Q&A is used in a hierarchical VIT, we improve upon previous models in various efficiency metrics, such as the number of parameters, floating point operations, and throughput, while preserving the model's accuracy. Our models also transfer well to other tasks. For example, replacing CNN backbone with Q&A VIT improves the average precision of the DTER framework by almost 2%. Additionally, incorporating Q&A into DTER encoder boosts performance, especially on small-scale objects. Q&A can be used as an upsampling layer, where we compute a single output per query. We improve upon different autoencoding methods in various reconstruction metrics. Please join us at our poster, and I will be happy to answer any of your questions. Thank you for your time, and keep on jazzing.